Hello and welcome to another episode of 8 equals -3. This is Orin Otter broadcasting live and pre-recorded from my studio at OtterTunes. I would like to take a moment to talk to you about acid. And no, not the type of acid you're thinking of. I'm talking about amino acids. Now, as part of the theory of evolution, we have been taught that one day, long ago in the primordial ooze, some amino acids just happened to assemble themselves into a working protein, and that was the beginning of life. Well, actually, it wasn't. It was sort of kind of the precursor to the beginning of life. But it was part of the process. But what really is the probability of that happening? In high school biology, our teachers taught us that there are exactly 20 amino acids. What they should have said is that there are 20 amino acids involved in protein synthesis. These are glycine,
alanine, serine, threonine, cysteine, valine, leucine, isoleucine, methionine, proline, phenylalanine, tyrosine, tryptophan, aspartic acid, glutamic acid, asparagine, glutamine, histidine, lysine, arginine.
But that's not all the amino acids there are. Now here are the names of just a few of the other amino acids. Formylmethionine, selenocysteine, pyrrolysine, beta-alanine, Y-aminobutyric acid, I don't know why, 4-aminobenzoic acid, dehydroalanine, glycolic acid, diaminopimelic acid, lanthionine, norleucine, proline, pipicolic acid, homocysteine, homoserine, norvaline, carboxyglutamic acid, hypocene, pyroglutamic acid, thiolysine, quisqualic acid, penicillamine, canavanine, cephalosporin C. Now, to play nice, we're going to give molecules to man evolution the best possible chance. And we're going to pretend that amino acids can self-assemble into proteins, which they can't. And that there was, in fact, a primordial soup that was loaded with amino acids at some point. Now, I have not given you an exhaustive list. There are well over 50 amino acids, and the grand majority of those have both a right-handed and a left-handed version. Yeah, that's right. That gives us well over 100 different amino acids in the primordial soup. But for the sake of simplicity, we'll round down to 100. Now, purely because I am me, we're going to represent the self-assembling protein with blind bag pony toys. Let's say we're hoping for a working 20 amino acid protein. That's pretty small. One working protein, 20 amino acids. So we start with our first amino acid. We open the bag and we get Princess Celestia. Oh good, that's just what we needed. Now right there, we had a 1 in 100 chance of getting the right amino acid. Now let's say the next amino acid we need in our protein is Pinkie Pie. Whoa, we got a Pinkie Pie. Isn't that lucky? Now what are the odds of that happening? That's 1 in 10,000 right there. Next we're going to need a Twilight Sparkle. Well, there's a Twilight Sparkle. Ooh, how lucky is that? That's a 1 in 1 million chance. And what's the chance we're going to get a Zircora next? Well, 1 in 100, of course. But the chance of getting all 4 of those in sequence, that's 100 million. And if we need a Crystal Rainbow Dash next, right there, that's 10 billion. And the probability keeps going up by 2 orders of magnitude each time. Rarity makes it 1 trillion. Applejack makes it 100 trillion. And with our next amino acid, the odds become 1 in 10 quadrillion. That's an Academy record right there. And with each protein we add, we continue to go up 2 orders of magnitude. I told you they don't like to self-assemble. And there, we now have our 20 amino acid protein. The probability of getting this exact combination is 1 in 1 undecillion. That's a 1 with 40 zeros after it. Now, most proteins are not nearly that short. So, let's say we wanted to continue on and create a working protein that is 100 amino acids long. The probability of that happening is literally 1 in a Google. That's a 1 with 100 zeros after it. Hey, I ran out of ponies. Actually, I lied. I was being generous. It wouldn't be a Google. It would be a Google squared. Now, how many proteins are necessary for life to exist? Well, I've heard an estimate of 50,000 proteins for a single species. I think that's actually a pretty conservative estimate, but let's go with it. If we assume each protein to be 100 amino acids long, what is the probability of the proteins necessary for life self-assembling, assuming that they could? The odds would be 1 in 10 to the power of 10 billion. It's a 1 with 10 billion zeros after it. There isn't even a name for that number. The only possible conclusion we can draw, to put it into simple English, sorry evolutionists, it didn't happen. Until next time, this is Or an Otter for 8 = -3.